Hello geometry students. Today we are working on 6-3 properties of parallelograms. You can put your name, date, and period. We have multiple learning targets today, and students will understand and apply theorems of parallelograms such as consecutive angles are supplementary. And if you remember, supplementary means they add to 180 degrees. Opposite angles are congruent. That means they are equal in measure. And the third property is that diagonals bisect each other. Okay, so we're going to work in a little different fashion where we'll go over theorems and how that theorem is applied. Your vocabulary is parallel lines, rectas paralelas. Theorem 6-7. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, so this is all today about parallelograms. So opposite sides are congruent. And in the picture, it looks like so. WX is congruent to XY, opposite sides. And WZ is congruent and parallel to XY, and therefore they are congruent. So how does that apply? In this first example, given a parallelogram WXYZ, what is YZ? So I want to know, what is this side? Well, if the opposite side is 327 or 3.27, then YZ is equal to 3.27, whatever those units are. Now let's apply it using algebra. Quadrilateral PQRS is a parallelogram. What is the length of each side of PQRS? All right, they want to know each side. All right, so first we'll figure out these sides just because the algebra looks a little easier. We'll write it as 4x equals 5x minus 3. So now I have to solve for x. And once I solve for x, I can just plug x into any of those x's above in the parallelogram to figure out the sides. So how do we solve this? I have 4x equals 5x minus 3. I'm going to get variables on one side. So this cancels, leaving us with negative x equals negative 3. Right? 4 minus 5 is negative 1. And now, maybe I should put the negative 1 just to make it easier for you to see. Negative 1x, right? 4 minus 5 is negative 1. So now I'm going to divide by negative 1. The 1's cancel, leaving us with x equals 3. All right, but that's not what they asked for. They said, what is the length of each side? So I'm going to list the sides over here. We have PQ and the opposite side RS. Then we have QR and PS. All right, so first one I'm going to find out is PQ. And we plug in 3 to x, and that is 4 times 3. So that is going to equal 12. Then for RS, which is also the opposite side, I don't have to do any math because they're congruent. It equals 12 also. Now we want to think about the other sides. QR, and PS. So I will want to plug in the 3 to one of those. Would you rather plug it into the 7x or the 2x? I think the 2x is a little easier. So 2 times 3, I'll show that math. 2 times 3 plus 12. So 6 plus 12 is 18, which means that PS is also 18 because they are parallel and it's a parallelogram, opposite sides. Okay. There's a QR code here, so normally I say don't take your phones out when we're doing notes, but in this case, if you are going to scan the QR code to follow along, you are welcome to do so. And I'm going to try going to this website, see if it'll work. Open link. All right, I did open it. 11 parallelogram examples in real life. This goes through, there's a bunch of ads. The properties of parallelograms, which we just went over, and you can read, it looks like they have more than just the ones that we went over, so you can read those properties if you'd like. We have tiling, so we can use parallelograms in tiling floors. They use it in architecture. That's really cool architecture where there's a bunch of parallelograms. Roofs are made from parallelograms. You can make origami using parallelograms. Some desks use parallelograms. Eraser, solar panels, and how they're built. So if any of this is interesting to you, you can read about it. A striped pole is painted with parallelograms. The steps of a staircase. The design on a cardigan. The structure on the fretboard of a guitar. And those are examples of where parallelograms are in real life, and knowing the properties of parallelograms can help you work with these ideas, these things that happen. On the back side of our notes, we have more theorems to go over. Theorem 6-8. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So this is the next theorem. In a parallelogram, consecutive angles are supplementary, meaning they add up to 180. So let's look at this. If they're parallel, which they are, then the measure of angle A and the measure of angle B add up to 180. And B and C add up to 180. C and D add up to 180. And I need another highlighter color. A and D angles add up to 180. Given the parallelogram ABCD, what are the measures of angle A and the measure of angle C? All right. Well, I can say that A and D are supplementary, which means that this angle A must add up to 180 when we add 114. So the measure of angle A plus 114 degrees must equal 180 degrees. If we subtract these two numbers, we can figure out what the measure of angle A is. So 180 minus 114, the measure of angle A is equal to 66 degrees. If we know that, we can figure out all of the other angles. So angle C would also be 66 degrees because it's supplementary with D. What is the measure of angle B? Well, it would have to be 114 because it would have to add with 66 to get 180. So the measure of angle B is equal to 114 degrees. Use the parallelogram shown. A. Given parallelogram GHJK, what is the value of A? All right. Using our theorem, we can say that H and G are supplementary angles, which means they must add to 180 degrees. So we're going to do A plus 5, that's angle H, plus angle G, which is 8A minus 5, adding those two angles together, has to equal 180 degrees because of the supplementary theorem. Okay, so let's collect like terms. If we have an A and we have an 8A, then that's going to become 9A. And if we have 5 minus 5, well, those just cancel. We don't need to worry about them anymore. So 9A equals 180 degrees, which means that A must equal, if we divide by 9, 20 degrees. Then it's asking, if we know that, then what are the actual measures of all of those angles? So we're going to have to plug this in. And I'm going to plug it into this one first. So if we plug in there, then the measure of angle H is equal to 20 plus 5, so that equals 25. And then the measure of angle G, we're going to plug it into here. So that's going to be 8 times 20 minus 5. So 160 minus 5 is 155 degrees. So then which ones are congruent? So H is congruent to K. And that comes from the next theorem that we're going to talk about, that opposite angles are congruent. So the measure of angle K also equals 25 degrees. And then the measure of angle J is going to be congruent to angle G because they're opposite. So the measure of angle J is also going to equal 155 degrees. Okay, and maybe I'll just recolor these so that it makes it easier for you to see that this is angle H and it is opposite of angle K, and angle G is opposite of angle J. If quadrilateral, so our next theorem, if quadrilateral is a parallelogram, then opposite angles are congruent, and that's what we just covered. So A and C are congruent, B and D are congruent. Our last theorem is theorem 610. If a quadrilateral is a parallelogram, then its diagonals bisect each other. All right, so that means that in this center, these lines are bisected. So A to W is right here, and we can show that they are congruent in measure. this is congruent using tick marks. And then XA, or AX and AZ are congruent. So AX is congruent to AZ, and AW is congruent to AY because they are bisected. Use the parallelogram RSTU with SU is equal to 35. So I'm going to highlight that in the diagram. SU. That's 35, that whole length. And KT is congruent to, or is equal to 19. They want to know what is SK. So we're going to write a formula. SK plus, so from here, S to K, if we add that to KU, then we get the whole length, which is SU. And SU, they told us, was 35. And SK and KU are the same, and so we can just write them as 2x. Because we can assume, if they're the same, we can just call them both x plus x. Now we can divide by 2, and x equals 17.5. So that means that SK is equal to 17.5. Now you can skip all of this algebra and just say, oh, 35 divided by 2 equals 17.5. Part B. What is RT? So RT is going to be equal to KT plus KR. And together those are equal, they're equivalent. And so if KT is 19, then KR is also 19. So what would this have to equal? 38. RT is equal to 38. And again, you could have skipped all of the algebra and just times this by 2 to figure out RT. That concludes our notes for 6-3 Properties of Parallelograms.